Welcome back to the Greater Essex County District School Board calendar, where we are exploring the fundamentals of mathematics. Each month, we are diving into a big idea from the Ministry of Education's Focusing on the Fundamentals of Math, a Teacher's Guide, and in particular, the table summarizing curriculum expectations from our current Ontario mathematics curriculum that always has been and will continue to be fundamental for developing students' understanding and proficiency in mathematics. Let's extend our focus from developing mental math skills and understanding of math facts to proficiency with operations. In particular, we're going to extend our learning from positive whole and fractional numbers to integers. Yes, that's right. We're going to start looking at negative numbers as well. But we're going to start with a very low floor. So let's begin with a quick exploration. Have a look at the screen. How many dots do you see? All right. On the screen, I'm hoping you see 8 dots just like myself. I see 2 groups of 4. You might see 4 groups of 2, or you might have just counted them 1 to 1. But what happens when I introduce a couple more dots on the screen? Interestingly enough here, it's harder to count. We could say there's a total of 8, 9, 10, 11 squares. But watch what happens. Because we have red squares and black squares, have a look at what happens when we put a red square and a black square together. They vanish just like that. And we're left with 5 black squares. Okay, let's try another. Here we go. And a couple more red squares for you. All right, how many squares will remain and what will the color be? Well, if you're like me, and if you're like my children, who at the time were in kindergarten, they knew that for every red square, a black square would disappear with it. So let's go ahead. Doesn't matter which ones disappear, but at the end, we can see that we have a total of 7 black squares. Pretty easy, right? What you're seeing here when we do this activity is you're actually experiencing what we call the zero principle. And when we look at these dots and we actually try to determine how many will remain, in this particular case, it really doesn't matter what the black squares or the red squares represent, as long as we get this understanding that one is going to be this thing we call positive numbers, and the other is going to represent negative or removal, or the fact that it's the opposite of the positive. So here, when we see this zero principle in effect, we're left with a total of 7 black squares. Pretty easy stuff. All right, let's look at another scenario. Here, we're going to start with some red squares. And the question I have for you is, what if we remove or take away 2 red squares? How many will remain? Well, again, most people would have no problem with this. We just simply swipe away 2, and we can see the result is 7 red squares remain. Nothing too tricky there. All right, now here's another. We have 7 black squares on the screen. Take a look at what happens next. And we're left with 8 black squares. What just happened there is we actually took 7 and we've subtracted -1. But we didn't have a -1 to take, so we had to utilize the zero property in order for us to make that happen. Let's do another. Here's another for you. Here we have 5 on the top, 4 on the bottom. We have 9 black squares in total. So we have 9, and I'm going to call them positive, but you could really call it negative if you'd like. We're going to call this positive. 9 positive, and look at that. The zero principle introduces 1 black and 1 red. Oh, another black and another red. And 2 reds are removed. So what that represents there is 9 minus -2. But we didn't have any negatives on the screen, so we had to introduce them using the zero principle. So we added a negative and a positive to the screen. We did that twice so that we had the 2 negatives that we could remove. And our result is positive 11. 9 minus -2 is positive 11. When we do this visually, and when we give students an opportunity to notice and wonder, they can actually build their conceptual understanding before we introduce symbols and notation, which often becomes too procedural, too fast. All right, let's get a little more explicit. We have 4 black squares, and the question we have is, if we take away 2 red squares, how many will remain? Again, we don't have any red squares. The only way we can bring red squares into the scenario is using the zero principle. So we're going to introduce 1 black and 1 red, which is the same as 0, because 1 minus 1 is 0. And I need another red, so I'm going to use the zero principle a second time, and we can now remove those 2 red from the screen. So how many will remain? Well, it looks to me like we're going to have 6 black squares that remain. Pretty cool. Let's do one more here. All right, here we have 7 red squares. If we take away 3 black squares, how many will remain? Well, we're going to have to go ahead and use the zero principle 3 times. Here's 1 time we've used the zero principle. We've introduced a black and a red, which doesn't change how many are there, because remember, when we put a black and a red together, it's 0. So by doing that, we haven't changed the quantity on the screen, even though it looks different. I'm going to do this again because we need another black square. And finally, one more time, we're going to use that zero principle, and we can go ahead and now remove those 3 black squares. The result is 10 red. So we had 7 red before. We wanted to remove 3 black. We ended up with 10 red. All right, let's move from this exploration and let's bring in a number line. And we're going to formally start using symbols to represent our black and our red squares. So let's have a look at an example, and we're going to use a number line to help us here and model the scenario. Here we have 4 black or 4 positive squares, and we want to remove 3 of them. Well, if we go ahead and place them on the number line and then remove 3, we're left with 1. Pretty obvious, pretty easy. Well, now let's have a look at a slightly different scenario. Let's look at 7 red squares, which are 7 negative squares. And we want to remove -4 squares. So we want to remove 4 negatives. Well, let's look at this on the number line as well. We know -7 would be on the left side of 0, and we're going to remove -4, or 4 of the red squares. We're left with -3. Pretty easy stuff. All right, let's keep going here. Now we have 5 positive squares. We want to remove -4 squares. Uh-oh, this one's a little harder. I can't remove 4 negatives because I don't have any negatives. So what do I have to do in order to get some negatives to remove? Well, we can use the 0 property. Since every black and red combine to give us 0, because one's +1, the other's -1, when we add those together, we get 0. So by adding 4 black squares and adding 4 red squares, we're essentially adding +4 and we're adding -4. So the effect is that the quantity actually hasn't changed. We now just have access to those 4 red squares. So let's go ahead and let's actually remove them from the situation. And then on the number line, we could double check and say, wait a second, my result is 9. 5 minus -4 is 9. Interesting stuff for sure. All right, let's try one more. We have -6 here, and we want to remove 1. Uh-oh, this one's another hard one because I can't remove +1 because I don't have any positives. But the zero principle can help us again. Let's go on and use that zero principle. So we're going to introduce a black square and a red square, and we will remove the +1. And what do you know? We are left with -7. Awesome stuff. All right, let's move into multiplication. All right, we have 4 groups of -2. All right, we know that -2 is represented, or all my negative values are represented by red squares, and we need 4 groups of -2. So let's go ahead and do that. We can do that by giving our 4 groups set up and ready to go, and we're going to put 2 red in each one. There's 1 group of -2, 2 groups, 3 groups, and 4 groups of -2. Well, let's go ahead and figure that out. We can tally that up, we can count that up, or we could even just place them on the number line and we'll see we have -8 as our solution. Now noticing that the commutative property works here as well with negatives. 4 groups of -2 is the same as 2 groups of -4. Doesn't change anything. All right, let's keep going. We have -2 groups of 5. Let's think about that for a second. -2 groups of 5. Well, what that's really saying is, well, one way of looking at this, there's multiple ways to look at how this or what this really means. We could look at this as -2 groups of 5 is subtracting 2 groups of 5, or taking away 2 groups of 5, or removing 2 groups of 5. So when we go to do that, I need to access the zero principle again, and I'm going to go ahead and remove 2 groups of 5. There's removing 1 group of 5. Now I've removed 2 groups of 5, and look at what we're left with. We're left with 2 groups of -5. Essentially what we've done is it's almost like we've forced the commutative property to work for us here through our interpretation. That's the same thing as removing 5 groups of 2. Removing 2 groups of 5 is the same as removing 5 groups of 2, and we're left with -10. Let's have a look at another scenario. Here we have -2 groups of -3. All right, so one way we can interpret this is that we want to remove 2 groups of -3, or we want to subtract 2 groups of -3, and we need to utilize the zero principle here. So we're going to go ahead and we're going to create ourselves 2 groups of +3, 2 groups of -3, and we're going to go ahead and remove 1 group of -3. We're going to remove 2 groups of -3, and guess what? What we have is 2 groups of +3 left over. So when you think of those rules, when we think of our multiplication rules and division rules for integers, there is a reason why they work. When you multiply 2 negatives, you get a positive because of the zero principle and this idea that we have to remove groups of -3, and the result will be 2 groups of +3. This video was intended to just scratch the surface of some of the ways we can help our students develop proficiency with integer operations. We hope you've enjoyed this video from our Fundamentals of Mathematics series. We'll see you in the next part, where we'll wrap up this series by exploring operating with fractions. See you then.